So this is a project done by Dana Folk, Megan Rosencrantz, and Emma Martin, and we are doing a roller coaster project. Our question is, you are going to ride on a super duper roller coaster. However, you are very scared to ride it and feel that if you do physics while waiting in line, it might calm your nerves. Here are some questions you decide to answer. A, what is the velocity at point A? So first off, we're going to write out the equations that we need to use for this. Gravitational energy is mgh, and kinetic energy is 1/2 mv squared. So we're doing mgh plus 1/2 mv squared for the gravitational energy of the roller coaster at 100 meters, and then the velocity at the beginning is equal to mgh plus 1/2 mv squared at point A. Now we're going to cancel out all the masses, since mass is the same the entire time and we don't need it. So we're going to rewrite the question as gh plus 1/2 v squared is equal to gh plus 1/2 v squared. Next, we're going to plug in the numbers, and we are using 10 for gravity. So we're going to do 10 times 100, because the roller coaster is at 100 meters at the beginning, plus 1/2 times 20 squared, because 20 is its initial velocity, is equal to 10 times 0, since at point A it doesn't have a height, plus 1/2 v squared, and we're trying to find what that v is. When you multiply the numbers together, you get 1,200 is equal to 1/2 v squared. Next, we're going to multiply the halves on both sides and then square root it. So we get v is equal to the root of 2 times 1,200. So velocity is equal to the root of 2,400, which is 49 meters per second. So the velocity at point A is 49 meters per second. Next question is, what is the velocity at point B? We use the same equation, so we do 1/2 mv squared plus mgh is equal to 1/2 mv squared plus mgh. However, we don't need mgh for point A since there is no there is no height. So it's just 1/2 mv squared is equal to mgh at point A is equal to mgh plus 1/2 mv squared at point B. Now we cancel out the masses again and get 1/2 v squared at point A is equal to gh plus 1/2 v squared at point B. When we plug in the numbers, we use the 49 meters per second we got in the last problem, so 1/2 times 49 squared is equal to 10 times 50 plus 1/2 v squared, and we're trying to find what that v is. When you do the computations on both sides, you get 1,200.5 is equal to 500 plus 1/2 v squared. So we subtract 500 from both sides and get 700.5 is equal to 1/2 v squared. Next, we multiply each side by 2 and then square root the sides. So you get v is equal to 2 times the root of 700.5. Or the root of 2 times 700.5, sorry. So now we get v at point B is equal to 37.5 meters per second. The next question is, what is the energy at B? To figure out energy at B, we do 1/2 mv squared plus mgh at point B. And in this question, we need to keep mass because mass doesn't cancel, even though it's the same. So we do 1/2 times 50 times 37.5 squared, since we got the 37.5 in the last problem, plus 50 times 10, because we're using 10 for gravity, and then 50 again for the height. When you do the math for both sides, you get 34,225 plus 25,000. And then added together, you get 59,225 joules, since energy is measured in joules. This is the roller coaster problem that we did.